Alrighty, a couple of harder examples coming here involving multiplication and division. But the main thing to remember, if we multiply terms, we add those powers. And if we divide terms, we subtract the second power from the first. That's what all these examples, no matter how hard, how easy they look, that's what it all hangs on. So, let's have a look at our first one here. I've got a to the power of 4 over b cubed times b to the power of 6 over a. Right, well, I can just write that as a single fraction. So I'll have a to the 4, b to the 6 over a b cubed. Now let's get this power of 1 in here. So straight away, a fraction is just the same as a division, and I'm going to treat each of my pronumerals separately. So I've got a to the 4 divided by a, which is just a cubed, and b to the 6 divided by b to the 3, which is b to the 3. Okay, that's our final answer. We can't combine those any further, but we have made it a little bit simpler. What if I've got something like this, where I've actually got my bases as numbers and my powers as pronumerals? Well, that behaves absolutely no differently to something like x to the 5 times x to the 3. We have the same base here, which is 2. Our base doesn't change, that doesn't become 4. I add the powers. Difference is we just don't know exactly what the powers are there. They could change. If I've got 2 to the a times 2 to the a plus b times 2 to the 3a minus b. Okay, well, again, same deal. My base is 2. I add my powers. So I have a plus 3a is 5a. And I've got b minus b. Well, I'm then just left with 2 to the power of 5a. That's as far as we can go at this stage. So the main thing is, if I've got these same bases and I'm multiplying, I just add my powers together. One last example involving a little bit more work, but I want you to see that the skills are exactly the same. A few different ways we could do this one. I've got 3a to the 5 bc cubed over 6a to the 4c multiplied by 4b cubed on 2abc multiplied by 2a cubed b squared c over 2a squared b to the 4c squared. Alright, looks like a big mess. Straight away I'm just going to add in the ones. Make sure I remember that they are there. Everything's multiplying. That's what makes it really nice. So I think we should just go and multiply everything in the numerator, everything in the denominator, and see where we end up. So I've got 3 times 4 is 12, times 2 is 24. a to the 5 times a to the 3 is a to the 8. b times b cubed times b squared, 1, 2, 3, 4, 5, b to the 6, times c to the 3 plus 1 is c to the 4. Don't need that times symbol in there. Doesn't matter if you've got it. On the bottom, 6 times 2 is 12, times 2 is 24. A to the 4, 5, 6, 7, a to the 7, b to the 1, and 4, b to the 5, and c to the 1, 2, 3, 4. Alrighty, now we're going to divide them as 3 separate terms. So I'll end up with 24 over 24 becomes 1 over 1. a to the 8 over a to the 7 just becomes a. B to the 6 over b to the 5 just becomes b. And c to the 4 over c to the 4, well, they just become 1s as well. So I'm left with just ab, or ab over 1. Both have a power of 1. Don't need to write that there, but that's what they are. So that obviously, this one looks much harder than the first couple we presented, but it only relies on those exact same skills to try to simplify that down a whole lot from this down to just plain old AB. So I hope that helps. Feel free to ask any questions if you need them.